Okay, so this, this lesson here is called Indirect Measurement, as you can see. It's actually really an important one. I mean, it's really, why we would, a really good example of why we might care about similar triangles in the real world. Sometimes there's things you can't solve by measuring directly, but if you can create similar triangles and measure a part of each triangle, you can use the fact that they're similar and use the scale factor to calculate the unmeasurable parts. Okay, so that's basically what you're going to be doing in here. The first thing that they want you to do is to go outside and use a mirror to create similar triangles. I'm going to have you skip that. Okay, I don't want you to worry about that. I'm going to have you just answer this question in here. How can you use similar triangles to calculate the height of any object? So the idea, well, one idea. The idea here is that these two angles are congruent, and therefore since you're standing straight up on the earth and the flagpole is straight up on the earth, then the idea is that you have angle similarity. That's the concept, so you can prove these two triangles are similar. And then you would be able to say, okay, the sides, if these triangles are similar, then the sides must be something we can measure, like the distance from you to the mirror, the distance from the mirror to the base of the flagpole, the height, your height. You can use that and you can calculate, well, what would be the height of this, this flagpole here. Okay, that's the idea. So when it says, how can similar triangles be used to calculate the height of the object? That I'll let you answer, but you would use that idea here, okay? You create a similar triangle, measure, calculate the, all similar triangles have a scale factor. Use the scale factor to measure the part that's unmeasurable. Want you to here just finish that. Don't worry about 2 and 3. And don't worry about 4 or 5. Just skip that right there. But here you're going to consider, this real problem here. Okay? So go to the part, use the mirror method, gather enough information to calculate the height of one of the trees. Figure shows your measurements. Calculate the height of the tree. One of the things that'd be really hard to know that you're seeing the top of a tree using a mirror like this. But, you can subtract from here the 4 feet to figure out what the distance here is, right? The whole thing is 16, so 16 take away 4 should tell you the length of this side, right? Then you would calculate, okay, your side, your height, and this height using the same ratio. And so basically you're writing, proportional statement. This side is to here in the same way as this side is to here. So, if this is 12, 12 to 4, 12 over 4 is equal to x over 5.5, right? I mean, that's the idea. Then you solve for x. And here she's just doing another one, the same kind of idea. They've given you the information that you need to basically solve this. You have 18 feet, you have 3 feet, you have her being 60 inches is 5 feet, so 5 feet, you got to draw it out. It's going to look like this, right? But 5 feet, 3 feet, and 18 feet, and you can use that to figure out how tall the tree is, okay? Here's another one. You could just use the shadows. This happens too, okay? And this is a really good way to do it. If you don't have a mirror, you know that the sun is coming at a regular angle. It's going to hit there. The same angle that your shadow creates with the sun is the same angle that it does. So you just find out your distance from the tip of the shadow here, know how tall you are, and then you have the distance from the tree base to the tip of the shadow and how tall it is. These are similar triangles. Okay, the sun's making that same angle here with you and with the tree. It's at the same angle of elevation, so these two triangles will be similar and you use the same technique. Here you have triangles. You would know this side, this short side here, and this side there has to be similar, right? So, I'm sorry, these two triangles are going to be similar, and the reason they're going to be similar is because you've got vertical angles, right? So if you drew this out, they walked down 50 feet, you walked 12 feet, you were 5 feet from the riverbank, and they were 5 feet from the riverbank. You would have to figure that your ratio of 12 to 50 is going to be the same as your relationship of 5, or the ratio of 5 to x plus 5, right? And that's what you would use. You'd say, okay, the river is x, so this side here is x plus 5, so 12 over 50 equals 5 over x plus 5. And you could solve that out, okay? Answer those questions, figure out the depth. Here you have another one. You have 60, same exact thing. 6 over x plus 8 is equal to, or you put x plus 8 over 6 is equal to 60 over 15. So you should be able to figure that out, how wide the ravine is. With this triangle, you have, again, you have similar triangles, so you're trying to figure out the widest point. You know that this distance here is 20 from B to C, and this triangle is 16, so 35 over 16 is equal to x over 20, right? That's pretty much all you have to do there, and solve it, and then you're done with this chapter.